10.7 talks about partial fractions. That's a big deal for our calculus sequence. Given a rational function where you have n of x divided by d of x, well, a rational function consists of polynomial divided by a polynomial. So if the denominator happened to be a product of distinct factors, then you would say, well, let's take the denominator and spread it out, always adding. And we want to write this as a proper fraction. If you recall, a proper fraction of course b can't equal 0, is where a is less than b. If b is bigger than a, if a is bigger than b, if a is bigger than b, then we could write a over b as c and some d over b as a mixed number. So, as far as rationals are concerned, we consider a rational function to be proper if the degree of n of x is less than the degree of d of x. And here, to get this, you would divide a by b to figure out what c is. And here you would divide as well. We'll talk about that when we get there. So 3 cases. Case 1, you have distinct solutions. Well, you list each one. Since this is linear, the top must be 1 power less. So the top is a constant. a1 is a constant, a sub 2 is a constant, a sub n is a constant. If the denominator happened to have some multiplicity of a linear factor, then I list that many times. And since this is linear, that counts as a constant. Since this can be written as the product of linear factors, then the top counts as 1 power less than a linear. It will count as a linear, so 1 power less will be a constant, and so on and so forth. If I get to a quadratic that's irreducible, cannot be factored, since the denominator cannot be written as the product of linear factors, it counts as quadratic. The top is 1 power less. 1 power less than a quadratic is a linear equation. So constant, we just use a or b or c, any of these letters. Linear, a linear equation looks like ax plus b, and quadratic would be ax squared plus bx plus c. So just to practice, example 1 states, write out the form of the partial fraction decomposition, do not evaluate. So since I can factor the denominator into x plus 2, x plus 1, I could say that x over x plus 2 into x plus 1, I can write that as a over x plus 2 plus b over x plus 1. And it doesn't matter which one you write first. It doesn't really matter. Those work out the same way. And the goal, of course, in the rest of the section is to find a and b. So there it is. If I look at the second example, I could factor an x cubed into x minus 1. So I could say 5 over x to the 4th minus x cubed is going to equal. This repeats, so I'm going to have to list it that many times, bare minimum. And that. Since that's linear, that's a. Since I could write that as, x squared. X times x, that counts as linear. And since that's linear, that's d. Of course, finding a, b, c, and d is the busy work. I get to the next problem. And I'm trying to take on all different combinations that we come across. So if I list this factors into x squared plus 1, so I could say 1 over x squared into x squared plus 1. That would be at least that many times. And x squared plus 1 I cannot factor. So this is linear. this is linear because I could write it as x times x. Since this does not factor and it's irreducible, that counts as quadratic. The top is 1 power less cx plus d. And the goal now is to find a, b, c, and d. Let me readjust these problems. Okay, to get d, I move d down. We notice this power is greater than this power. So before we proceed, we need to use long division. We can only use this method if this is a proper fraction. X cubed divided by x squared is x. That's x cubed minus 4x. Subtract 4x divided by x squared. Well, that's less, you're done. So that would be x, and the remainder is 4x over x squared minus 4. I could say that is x plus 4x over x minus 2 into x plus 2. So on this portion, this piece, I could say that is x minus 2 and x plus 2. And since that's linear, that's a and that's b. So if it's an improper fraction, this is the way to go. Okay, now let me look at the next problem. If I factor this, this is x squared plus 9 into x squared plus 4. So I could write this as a x plus b over x squared plus 9 plus, and since this is irreducible, cx plus d. I should have thought of learning this from the beginning. And if I look at f, well, the same deal, except here I will say this is x squared plus 4 quantity squared. So that's going to be x squared plus 4 plus x squared plus 4 squared. That many times. That's irreducible. That's ax plus b. Since this can be written as x squared plus 4 twice, it counts as quadratic, one of those, so that's cx plus d as well. And the goal is to solve those, of course. Find the partial fraction composition for this problem. So I'm going to say this is 1 over x plus 2 into x plus 1. And since those are linear, and I'm going to touch on every piece, that's a and b. Two ways of solving this. I'm going to show you how the BIC does that and how we're going to do that. The author says, well, get a common denominator. So method 1. Get a common denominator. So this is missing an x plus 1, and this is missing an x plus 2. So this is a into x plus 1 plus b into x plus 2. Since the denominators are the same, you could ignore them. 1 equals a into x plus 1 plus b into x plus 2. So whether I'm going to use method 1 or method 2, I need to get this far. So I should not put method 1. Now I should say method 1. Now I should say method 1. You will get rid of the parentheses. You will get the x terms and the constants, a plus b, and the constants are a plus 2b. And from this you generate a sequence, I should say a system of equations. A plus b, so there is no x there, that's a 0. And a plus 2b, this is the constant should equal to 1. And you solve multiply the top equation by a negative. That would be b equal 1. If b equal 1, a plus 1 equals 0, so a equal negative 1. There it is. So I got this to be a 1 and a negative 1, and I'm done. Now, the second case, case 2. Or I should say method 2. I will take this equation 1 equal a into x plus 1 plus b into x plus 2, and I would play with the forbidden numbers. What's the domain? X cannot be negative 2. Let x equal negative 2. I'll get 1 equal a times, if I put a negative 2, isn't that negative 2 plus 1, which is negative 1? And negative 2 in there will make that a 0. Doesn't that make a equal negative 1? And the second number I'm not allowed to have a negative 1. Let x equal negative 1. Put a negative 1, well that's 1 equal, negative 1 there, that's a 0. And negative 1 there, that will make it b times negative 1 plus 2 is 1, so b equal 1. And you see I got the same answer as we did up there. But this is a lot less work than this, especially if you have a 3 by 3 or 4 by 4. Of course there's a catch. You need those to equal 0 for this to work. So this is the method I'm going to stick with as I'm doing these problems. Here's another problem. I want to figure out where this fraction came from. So what I'll do, it didn't work. There we go. Better. So I'm going to say, you know what, let's factor that. That's x over x minus 4 into x plus 1. So since the denominators are distinct and linear, the top is a and b. That's simple. Either way, whether I use the book's method or our method, we're going to clear the fractions. So clear the fractions, multiply this by x plus 1 top and bottom. Multiply this by x minus 4 top and bottom. And here's the difference. Our method, we say let x equal, what's the domain? All real numbers except 4, let x equal 4. Put a 4 there. A 4 there, 4 plus 1 is 5. A 4 there will make that a 0. So automatically I know a is 4/5. And what's the other value? You can't have negative 1. Let x equal negative 1. And you get a negative 1 equal, a negative 1 there will make that a 0, plus b times a negative 1 there. Negative 1 minus 4 is negative 5. So that means b is 1/5. So my solution, 1/5 right there, and 4/5 right there, and I'm done. Of course, the book's method, I'm going to do it here as well. Just this time, they clear the fraction, the parentheses, and they say, well, look, get the terms with the x, give the terms without an x. That's a plus b, and that's a minus 4b. And from here, they get a system of equations. They say, look, the number in front of x must equal the number in front of x, so a plus b must be a 1. And they say the constant, the term that's a constant, must equal a constant, but there's no constant here. That means there's a 0. So you would say a minus 4b equal a 0. And then solve this system of equations. Multiply the top, say, by a negative 1. That becomes negative a, negative b equal negative 1. Add negative 5b equal negative 1, so b is 1/5 as you see. Plug it in and get the second case. So again, I am going to be doing this type of solutions. I'm not going to be working those out. You could if you want. This problem has an issue because the top is greater than the bottom, so we're going to have to go ahead and reduce it before we start. We're going to say that is x cubed divided by x squared minus 4, that's x. X cubed minus 4x, subtract. So this is going to be x plus 4x divided by x minus 2 into x plus 2. That's going to equal x plus a over x minus 2 plus b over x plus 2. So I want to figure out, I'm ignoring the x, I'm taking this and figuring this out. If I clear the fractions, I'm looking at 4x equaling a into x plus 2 plus b into x minus 2. And our trick, what's the domain? X cannot be 2, let x equal 2. 2 in there will get you an 8 equal. A 2 in there, a 2 plus 2 is 4. A 2 in there will make that a 0, that means a is 2. And what's the other value you can't have? You can't have negative 2, let x equal negative 2. Negative 2 times 4 is negative 8 equal. A negative 2 there will make that a 0. A negative 2 there will make that a negative 4. So b is also a 2. And there's my answer.